Welcome to this predicted paper from onmaths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing. To find a fraction of amount, what we do is we divide by the bottom of the fraction times by the top. So we're going to do 60 and we're going to divide it by the bottom of the fraction, the denominator, which is 3. And 60 divided by 3 is 20. Then we're going to do 20 times 1, which will just remain 20. So our answer is 20 kilograms. So with this question, we need to first of all count how many sides this polygon has. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's 10 sides. And we just need to know that a 10-sided shape is a decagon. Now we are expected to know all of the names of shapes between 3 and 10 sides. So if you don't know them already, just sit down and learn them. So a prime number is a number that is only in the 1 times table and its own times table. So 4, for example, is not a prime number because it is also in the 2 times table. 6 is in the 2 times table. 15 is in the 3 times table. 21 is also in the 3 times table. 9 is also in the 3 times table. Now 1 is a bit of a special case. The definition is that it has to be in 1 and its own times table, and technically 1 is only in one of those, so 1 is not a prime number. The smallest prime number is actually 2, but 2 is not in this list. 23 though is not in any other times table, so 23 is a prime number. All angles around a point add up to 360 degrees. So we've got this angle here, which is 25 degrees, and we've got this angle here, which is currently unknown. So to find out what A is, we're going to take away that 25 from 360. And when you do that, you get 335 degrees, which is our answer. You'll often need to write down the reason, which is angles around a point add up to 360 degrees. So if we do our place value grid, and so we've got units here, tenths and hundredths. Don't think we need any more. So we can put in our number, it's 5.87, and you can see here that the 8 here is in the tenths column. So the 8 represents 8 tenths. Here we're given or asked for a cube root of a number. So what we need to do is we need to understand first of all what the cube root of 125 is. Well, I know that 5 to the power of 3, 5 cubed is 125, and that's something you need to know off by heart. Therefore, the cube root of 125 is like the opposite, it's the inverse. So the cube root is the inverse of cubing, so that's going to equal 5. So if the cube root of 125 is 5, what's the cube root of minus 125? Well, I know the cube root of 125 is 5 because 5 times 5 times 5 is 125. 5 times itself 3 times is 125. So what times itself 3 times is going to equal minus 125, where it's going to be minus 5 times minus 5, which would be positive 25, times minus 5 will be a negative minus 125. So our answer is going to be minus 5. So I'm going to just copy that number down again, just make it a bit bigger so we can see what we're doing. Okay, we're asked to work that out, round it to 3 significant figures. That means 3 numbers from the left hand side. So starting here, 1, 2, 3. Now it's the first number has to be not a 0. So if it was a decimal, we would start counting as soon as it wasn't a 0. After that 4 then, we're going to put a line down. Now all the numbers are going to turn into 0 on the right hand side. So these numbers here will all turn to zeros. But before they do, we need to look at this number. Now this number is a decider number. If it is 5 or more, then it will push this number up by 1. If it's less than 5, then nothing will happen. Because it's less than 5, all the numbers to the right will turn into zeros. And with decimals, if they're zeros, we don't need to write them. So the answer would be 30.4. So we're going to start off by writing the sequence out. And what you might notice straight away is that each of the terms is increased by 2. And so we're asked to find the next 2 terms. So we're just going to keep this pattern going. So increase it by 2, that would be 20. Increase by 2 again, and that would be 22. Congruent means that it's a shape that is exactly the same as another shape, but it can be rotated, translated, can be flipped around, but it's basically the same shape. So I imagine cutting it out onto cardboard and trying to fit it into the other shape. If it can fit, then they are congruent. So looking at the shapes, we've got some triangles, we've got some weird looking shapes, but I'm going to look at A and I'm going to draw A in. So I'm just going to trace A, and what we can notice is if I manipulate that now and if I bring it down to E, it kind of almost looks the same as E, but what I can do is actually just reflect it and it's exactly the same as E. So A and E are congruent. Median means middle of an ordered list. Now, when numbers are put in a stem and leaf diagram, it means by default they are in order. So we're going to cross out the smallest and largest number. So the smallest number is the 4 here. Well, actually that represents 34. The largest is this 69 up here. Put a pen away. Then cross out the smallest. Well, the next smallest is 39. And the next largest is this 59. So I'm always going to the top left, then the bottom right. So the top left number is this 43. Bottom right number is this 54. Top left number is this 44. Bottom right number is this 53. Now, here's a problem. We're left with 2 numbers in the middle, this 49 and this 52. So whenever we're left with 2 numbers, what we do is we add them together, divide by 2. So to find the median, we're going to do 49 plus 52, and we're going to divide that by 2. So 49 plus 52 is going to be 101, divided by 2. And 101 divided by 2 is 50.5, or 50.5. And again, realise that 50.5 is halfway between 49 and 52. So I'm going to start just by copying this question. When we're told to solve, it means we need to find out what x is. And there's a nice little strategy to be able to do that. And the first thing we do is just draw lines left and right of the equal sign. And we look at the left-hand side and work out what is stopping x from being on its own. Well, this minus 10 here is stopping x from being on its own. So we need to get rid of that somehow. And we do that by doing the opposite of it. So what is the opposite of take away 10? Well, that's going to be plus 10. But you can't just do that to the left-hand side. You have to do the same thing to the right-hand side. So on the left-hand side now, we're left with just x because we've got rid of that take away 10. And on the right hand side we do 6 plus 10, which is 16. So our solution is x equals 16. Here we have a triangle and we've got an angle of 48 degrees. We've got this right angle which is 90 degrees and we're looking for x. So what we need to do is we need to realise that the 3 angles will add up to 180 because it's a triangle. So what we're going to do to find x is just subtract the 2 angles which we know. So we're going to subtract the 90 degrees plus the 48 degrees from 180. And in brackets we're just going to say the reason, and it's angles in a triangle add up to 180 degrees. So when we do that, we do 180, take away 90 plus 48, and you get 42 degrees. So a composite bar chart is where you'll stack the bar charts on top of each other. So we're going to start with this 12 here. And so I'm just going to do a bar up to 12. And these lines go up in twos, so it would be there. And then we're going to do this females. So we've done the males, we're going to do the females. And the females is only going to be one high because they're going up in twos. And we need a way of showing male or female. So what I'm going to do is just shade the female there, and I'm going to just draw a key. I'm going to say if it's not shaded, it's males. And if it is shaded, it's females. Okay. Next we're going to do the 8 and the 4. So what you can do is just do the whole thing, then split it afterwards. So it would be like that. Shade in the females. And then finally we've got a 4 and a 12. And let's shade in the females there. Now don't spend forever on your shading, as long as it's clear which one's male and which one's female. So to solve this, I'm going to first of all just write out the question just to make it a bit bigger. First thing we do is put in our solving lines. So we just put a set of lines to the left and the right of the equals. And what we need to do is get the x on its own. So looking around, there's this 11 we want to get rid of, and this take away 5 we want to get rid of. Always get rid of the plus or the take away first. So we're going to focus on this minus 5. We've got to figure out what is the opposite, what's the inverse of take away 5. Well, the inverse is going to be plus 5. Now we can't just do that to the left hand side, we've got to do it to the right hand side as well. So we add 5 to both sides. When we add 5 to the left hand side, we're just left with the 11x. On the right hand side, we do 28 plus 5, which is 33. Now, we still don't have x on its own. We've got this 11 here. Now, what is that 11 doing? Well, that 11 is a times 11. It's multiplying x by 11. So to get rid of it, we need to do the inverse of times 11, the opposite, which is divided by 11. And what we do to one side, we must do to the other side. So we're going to divide 11 both sides. That will leave us just the x on the left-hand side, and 33 divided by 11 is 3. So the word solve means find out what x equals, and we've done that. So football is represented as a quarter of this pie chart. And so if there are 60 students altogether, we just do 60 divided by 4 to find a quarter of it, and that's 15. So there are 15 people who picked football. To find a coordinate, what we can do is we can start in the middle and we work out how far across we have to go. And here we have to go 2 across, so the x coordinate is 2. Then we find out how far upwards or downwards we have to go. And here we can go, well, we have to go 3 downwards, so that's going to be minus 3. So we first of all look at the x coordinate, the 2, then the y coordinate, minus 3, along the corridor, up, or in this case down the stairs. In algebra, we don't show the times sign, so 17 times a times b just simply becomes 17ab. To be able to add or subtract fractions, we must make the denominators the same. So what we do is we write out the 5 and 7 times tables, so 5, 10, 15, 20, 25, 30, 35, and you keep going through each times table until you get to a number that's the same in both. You can see it's 35 here. So we're going to times top and bottom by something to make the denominator 35. So for this first one, it's going to be 7. So we're going to times top and bottom by 7. For the second one, it's going to be 5. So 2 times 7 is 14, and then the bottom will be 35, the denominator. And then 2 times 5 is 10, and the denominator will be 35. Then when we have that, we take away the numerators. So 14 take away 10 is 4, and that just leaves 4 over 35. So we can see whether we can cancel it, and we can't. So the answer is just 4 over 35. The midpoint of a line is just the halfway point of the line, and we can see that the halfway point will be here. And so the coordinates of that point are 0, 2. If we were to write this decimal in the columns, and some of you might not have used these columns in a while, but we have units here, we have tenths, hundredths, thousandths, that's all we need. So it's going to be 0.182. Now if you read off the number, it's 182 thousandths. So you just look at where the last digit is and look at what column it is, and reading the digits from left to right, you can put that number 182 over that last column, 1000. Okay, so it's 182 over 1000, but they're both even numbers, so we can actually cancel it down. It says it wants it in its simplest form, so we can divide top and bottom by 2. And 182, well 180 divided by 2 is 90, so that's going to be 91. Now I'm not sure, I don't think you can cancel that anymore, so I'm going to put that as my answer, 91 over 500. I'm going to start by working out what the building is, or the width of the building is in centimetres. So it says 33 metres, and I'm going to convert that into centimetres by timesing by 100. Okay. Now when it says it has a scale of 1 to 300, it means 300 in real life is 1 on our map. So all I need to do is divide it by 300 to find out what it's going to be on our map. So we'll just divide that by 300 and I get the answer of 11. So it's going to be 11 centimetres on our map. So with a stem and leaf diagram, the numbers in the middle often represent tens. They could be units. So we look at the key first of all, and we see that 3 line 9 means 93. So the numbers in the middle are going to represent 10. So this is a 90. Now we're looking for English, so this will be 92. So our first number will be 92. Then this will be 10 tens and a 4. So it would be 104. 11 tens and 1, so 111, and then 11 tens and 2. So to find the median, we go cross out the biggest and smallest until we're left with 1 or 2 in the middle. Here we're left with 2. So what we're going to do is we're just going to add the 104 to the 111, and we're just going to divide that by 2. So when we do that, we get 107.5, or 0.5. So our answer is 107.5. So we've got to first of all work out how many parts there are altogether. So we're told that the ratio of red, yellow and green is 3 to 2 to 4. So to work out how many parts there are altogether, we do 3 plus 2 plus 4, which is 9 parts. So there's 9 equal piles of sweets. Okay. But to work out what one part, or one pile of sweets is worth, we're going to get the 99 sweets and divide it by the amount of piles, and that's going to be 11. So one part is worth 11 sweets. We're asked to find out how many yellow sweets, and yellow is the middle one, so it's going to be the 2. So yellow has 2 piles of 11 sweets. 2 times 11 is going to be 22, so it's going to be 22 sweets. The difficulty with finding the perimeter of this shape is we do have some of the lengths missing, so we're going to find the lengths that are missing first, and then we'll find the perimeter. So the one on the right here is going to be the same as the one on the left, so this is going to be 5.6. Same with the one on the left of the 2.4, so this will be 2.4 here. This length here is going to be slightly more tricky to work out. What we do is we work out the total length across, or the total width across, which is 9.8, and we take away the bits that we know. So we take away these purple lengths at the bottom. So to work out the length of the missing bit, we're going to do 9.8, and we're going to take away the 4.3 plus the 1.2. And then when we do that, we do 9.8, take away those bits, we get 4.3. So this missing bit here is 4.3. So to work out the perimeter, we're going to start at the top left of the shape and add up all the lengths as we go around the shape. So 9.8 plus 5.6 plus 1.2 plus 2.4 plus 4.3 plus 2.4 plus 4.3 plus 5.6. When you add all those up together, you get 35.6. It's a perimeter, which is a distance, so our units are centimetres. So we can quickly draw a line of best fit for here, and it looks something like that. And if our line of best fit is increasing, like we have here, then we say the data is positive. If, however, the line of best fit is decreasing and looks like this, we say that it's a negative correlation. So positive if it's going up, which this one is, so it's a positive correlation. And if it's going down, then it's a negative correlation. If the data is all over the place, so it looks like something like this, where you've got the points everywhere, we say that's no correlation. Going to first of all work out how many parts there are in total. So we've got James with 9 parts, 6 for Andy, and 7 for Tia. So in total we've got 9 plus 6 plus 7, which is 22 parts in total. And we're asked to find a fraction Tia receives. Now Tia's the last one, so she is receiving the 7 parts. So it's 7 out of 22. To find the surface area of the cuboid, I'm just going to label the faces and do them individually. So we've got A, which is 24 by 13. So we're going to do 24 times 13, which is 312. Next we're going to do B, which is this one at the top, and it's 24 across and 8 is the length. So 24 times 8, which is 192. And finally C on this side here, which is going to be 13 times 8, which is 104. Now notice that the faces all have the exact same face on the opposite side. So this one at the back is also A, this one at the side is also C, and the one at the bottom is also B. So what I'm going to do is add up all the areas of the squares and double it. So to work out the surface area, we're going to do 2 times and then 312 plus 192 plus 104, and that will give me 1,216 centimeters cubed squared, because it's an area. So a stem leaf diagram is just a way of showing raw data. This 1 here could either mean 10 or it could mean 1. In this case we're using it to represent a 1, because if you look at the data they're all either 1 point something, 2 point something, 3 point something, or 4 point something. So looking at the 1 point somethings, we've got a 1.1 there, and we've got a 1.4. Looking at the 2 points, we've got a 2.1, 2.3, 2.4, and 2.8. Looking at the 3s, we've got 3.8, and looking at 4s, we've got 4.2, 4.4, and 4.7. And so in our key here, we're just going to pick this number here. It doesn't actually matter which number we pick. And we say 1 line 1 means 1.1 centimeters. A plan is a view that you would get if you were on top of the shape. So you were in an airplane or something looking down on the shape. So the sides of this that we'll see, well, we'd see this bit here, and we would see this bit here. So I'm going to start off with the first bit I shaded, and we've got to figure out what the different lengths will be. Well, this would be 2 centimeters across, and the whole thing is 8 centimeters. The bit we don't want is 3 centimeters, so this part here will be 5. It would look like it was 5 wide. So let's draw that on, and so we've got 2 centimeters down, and we've got 5 across. 1, 2, 3, 4, 5. And this is what it would look like from above. Now the other part will be same 2 centimeters, but it will be 3 centimeters across. So we have 3 centimeters across. Now whenever you have a join or a change in elevation, you need to show that with a line across. And so this will be our completed answer. All probabilities have to add up to 1. And so the probability it will rain tomorrow is 0.15. And so the probability it won't rain is 1 minus 0.15, which will be 0.85. To work out the circumference, we need to first of all work out what the diameter of this is. And to do that, we just draw a line across the circle, and we can see the diameter is twice as big as the radius. So the diameter is going to be the radius times 2, which is 28. Formula for the circumference of a circle is just pi times the diameter, which will be pi times 28. Now to write this in terms of pi, which the question asks for, we just put the number first and then pi. So it will be 28 pi. So this question is asking us really to divide the 5 3/4 by 1 3/4. So we're going to do 5 3/4 divided by 1 3/4, because we're finding out how many of each of these towels, which is 1 3/4 meter, can be made when the total amount of cotton is 5 3/4. So first thing we're going to do is convert them to mixed numbers, to top-heavy or improper fractions, because at the moment they're mixed numbers and we can't divide or times if they're mixed. So we times the 5 by the 4 and add it to the top, which will be 20, and then add it to the top 23, and then do the same. 1 times 4 is 4, plus it to the top is 7 over 4. Now a little trick here is KFC. We keep the first fraction, we flip the second fraction, and we change the divide sign to a times sign. So we're going to keep this first fraction as it is, change that divide to a times, and flip the second fraction. Okay, whenever we multiply, we just multiply the tops, so 23 times 4, which is 92, and we times the bottoms, which will be 28. And now we need to convert this back into a mixed number. So first of all, actually we can simplify this, because we can divide top and bottom by 4, so that would be 23 over 7, and then make this a mixed number. So 7's into 23 go 3 whole ones, and then obviously 2 remainders, so it's 2 over 7. Now it asks us for the amount of towels that she can sew patterns into. Now the issue here is that she will do 3 whole towels, but then have some left over, but she doesn't have enough to create a 4th towel, so it's just going to be 3 as an answer. The formula y equals mx plus c includes this m, and the m means the gradient. So if we're looking for something that is parallel to y equals 9x plus 18, we're looking at this number here. And for it to be parallel, it needs to have the same gradient. So we could just write y equals 9x plus or subtract anything. Or we could just write y equals 9x. I'm going to say plus 5. To find the pressure, we need the area and the force. And we're given the force in the question, and so all we need to do is find out what the area is, which will be the 7 times the 9, which which will be 63 centimeters squared. And the force is given to us in the question. So what we can do is write down the pressure formula, which says that pressure equals the force divided by the area. Force is given to us as 2268. The area we've calculated is 63. Divide the two and you get 36. So it's going to be 36 newtons per centimetre squared. So when you read this question, the question's basically asking you to find the bearing of O from B. So the lifeboat is at B, so I'm going to draw a north line here. And to find a bearing, you start from the north line and you keep going clockwise. So we're going to look for this angle here. Now, this angle, which is given to us in the question, and this angle here, which I'm just going to call x, are going to be equal. So x is going to equal 135 degrees. And the reason for that is we've basically got, and I'm just going to draw or extend the north line down, because we've basically got we have a set of parallel lines here, and we have a set of z angles, which we know is alternate angles. So the reason for that is it's alternate angles. And always show the reasons to the examiner. Okay, and so to find out what the bearing is, so the bearing of O from B, it's just going to be 360 take away 135, and the reason for that is angles on a point. We've run out of space. Okay, so we're going to do 360 take away 135, which is 225, and so our answer is 225. So we're told that from 14 people who liked football, so we've got 14 people here who said yes, they do like football. So we can fill up the 14 here. Now, we're told we started with 31. Therefore, if 14 liked football, then 17 must have not liked it. Carrying on the sentence, it says 4 like rugby. So 4 of those liked rugby. And we had 14 to start off with. Down this strand, and so that must mean that we've got 10 who don't like rugby. So of those 14, 4 liked rugby, so therefore 10 must have not liked rugby. But what about the bottom section, this part here? We've got 17 who didn't like football. Well, it says from the people who did not like football, 6 liked rugby. So we've got 6 there, and that must mean that we've got 11 who did not like rugby. So we know that 171 is 3 times 3 times 19. And what we do is we just compare 171 with 342. And we know that 171 times 2 is 342. So therefore 342 will have the same prime factors as 171, which is 3 times 3 times 19. But it will also have a times 2 in there. So the answer will be 2 times 3 times 3 times 19. So here we're asked to factorise a quadratic, and our answer will be x plus or minus something, x plus or minus something. So it'll be 2 sets of brackets with an x at the start. Okay, so to be able to find out what's in the bracket, we look at the 36 there, and we know that we're going to have to multiply 2 numbers together to make that 36, and we look at the coefficient of the x, that 15, and we know we're going to have to add these numbers together to make that 15. Now if you just can figure out in your head the answer, that's absolutely fine. If not, you can just quickly write down the factors of 36. Now because they multiply together to make a positive 36, they'll either both be positive or both be negative, but they add together to make a positive number. So we're just looking at the positive factors. So 1 and 36, 2 and 18, 3 and 12, 4 and 9, and 6 and 6. And we're looking for which ones of those add together to make 15. And we can see here it's going to be 3 and 12 add together to make 15. So our two numbers are going to be plus 3 and plus 12, or the other way around. Sometimes it's easier with these questions to multiply both numbers by, say, 10 or 100 or 1,000. So if we look at the 0.06, if we times that by 100, it would make the question a lot easier. But with a division, if you times one of the numbers by 100, you have to times the other one by 100. So we just go times the 30 by 100, and times the 0.06 by 100 to make that 0.6. And this actually is the same calculation as 30 divided by 0.06. The reason being is that you can write that as a fraction. And you know with fractions, you can just times the top by something and times the bottom by something. It doesn't change the fraction at all. It just keeps it exactly the same. So we're going to use the bus stop method to find out what that is. So we're going to divide that out. 6 doesn't go into 3, so carry that. 6 is into 30, go 5, 6 into 0, 6 into 0. So that's going to be 500. When proving two triangles are congruent, and congruent means exactly the same, we're going to have one of four answers. Either side angle side is the same, angle angle side, or angle side angle. Side 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 are the same, or they have the same right angle, hypotenuse, and side. This question doesn't have a right angle, so we can cross that out. It has two lengths, so two sides, but not three, so we can cross that one out. It only has one angle, so we can cross this one out. So we're looking to see whether it has the same side, then angle, then side. So here we've got 13 as a side, then 139 as an angle, then 6 as a side. 13 as a side, 139 as an angle, and then 6 as a side. So they have the side, angle, side. There is quite an easy way of doing this question, but I'm going to show you the long way, and then we're going to work out what the quicker way is. So I'm going to pair up the A and the 1, which it suggests in the question. Then I'm going to work out the A and the 2 as a different combination, A3, A4, etc. Then I'm going to look at the B and do the same thing, B1, B2, B3, etc. Then I'm going to work out the C, so all the combinations with C. So how many combinations are there with A? Well, there's going to be 7 because there's 7 numbers. How many with B? Well, there's also going to be 7. And how many with C? Well, there's also going to be 7. So in total, there's going to be 7 plus 7 plus 7, which is 21. And the way I can work that out easily is work out how many combinations there are with spinner 1. Well, there's 3. How many combinations there are with spinner 2? 7. And we just times the 2 together. 3 times 7 is 21. Integer just means whole number. So we're looking for all the whole numbers that satisfy these two inequalities. Well, the first inequality says that it has to be greater than 3. So the smallest number that is greater than 3 is 4. The second inequality says it has to be less than or equal to 8. So I'm just going to keep going till I get to a number that is less than or equal to 8. It can't be 9 because 9 is not less than or equal to 8. So our answer is 4, 5, 6, 7, and 8. I'm going to write this out just a bit bigger so we can see what's going on. And there are loads of different methods for expanding brackets. I'm going to use smile and rainbows. So smile there, rainbow there, and I always put a little notch here to remind me to times it. So we're going to do 4 times 8, which is 32, and x times x, which is x squared. Then we're going to do 4 times 3, which is 12, and x is just there. So when we expand that, we get 32x squared plus 12x. So we're asked to rotate the triangle A 90 degrees clockwise and the centre of rotation at 0, 0. So we're going to first of all just show where the centre of rotation is, which is at our origin. And what you do is you get tracing paper, trace out the triangle, and rest your pen or pencil at 0, 0. So I'm just going to draw it out. So just copy it out. And what you do is you'd push your pen into 0, 0. And unfortunately I can't do that. But when you rotate it 90 degrees clockwise, the shape will end up here. And so we just got to line this up perfectly. A little bit less rotation maybe. There we go. And then what you do is you'd lift your tracing paper and just draw in the shape underneath. And it says to label in the triangle as B. To find the smallest possible width, I'm just going to do a quick number line. And all I'm going to do is put 12.2 on our number line and figure out what the next number down will be. Well, if it's the nearest tenth, the next number down would be 12.1. That's the next number down it could have rounded to. And I'm just going to cut this number line in half and find out where our halfway point is. Well, the halfway point would be 12.15, and that's actually the minimum it could have been before it would have rounded to 12.1. So our triangle says that speed equals distance over time, and average speed is the total distance over the total time. So when we're looking for average speed, we want to work out, so we're just going to write average speed or speed, and it's going to be the total distance. So the distance starts at 0, goes up to 30. So the total distance is 30, and the time starts at 10:15 and ends at 11. So that'll be 45 minutes, or, well, we should do it in hours, because the units we want in hours. So it would be 0.75. So 30 divided by 3/4 would be 40. So it's going to be 40 kilometers per hour. When translating, we translate with vectors, and the top number in a vector tells us how far right, and the bottom number tells us how far up we go. And to translate a shape, you always pick a point. Now I always pick the top leftmost point, so I'm going to pick this one. And looking at the vector, it says we're going to go 2 to the right. So we do 2 jumps to the right, 1, 2. Now looking at the bottom, because it's -4, instead of going up 4, we're going to go down 4. So it would be 1, 2, 3, 4. So our new coordinate for the top will be here. And the next thing we need to do is draw in the shape. So that's the top left part of the shape. And so I'm going to draw in the shape, and it's 4 across, so it should go here, and draw in the shape in there. Make sure that you know that that coordinate is the top left part of our shape, and it says to label it B. The rules of indices say that when we multiply two numbers of the same base, and the base are the big numbers, then we add the powers. So we're just going to do that to the top fraction here. So it's going to be 5 to the power 13 plus 4, which is 17. And then that's going to be over 5 to the power 5. Now, what a fraction is basically is a division. So it's 5 to the power 17 divided by 5 to the power 5. And the rules of indices say that when you've got two numbers of the same base, which we do here, and we divide them, we take away the powers. So we're going to do 17 take away 5, which is 12. To find solutions for quadratics on a graph, all you need to do is find out where the graph meets the x-axis. Okay, so the coordinates this graph meets the x-axis are here, and that would be minus 0.8 and 0.2, and they're also called roots. When we estimate, we normally round to one significant figure. So what I'm going to do is just rewrite this question, but rounding everything to one significant figure. But I'm just going to miss out this square root for now. So 3.3 would just be 3, and 4.7 would just be 5. Now, the problem with this 27 is square rooting 27 is difficult, especially without a calculator, and estimating should be done without a calculator. But if I round it to the nearest significant figure, if I round it to one significant figure, that will make it 30. Now 30 is no easier to work out. So square numbers are a bit of an exception. When you've got square root, it's a bit of an exception. You've got to find it to the nearest square number. So 27 to the nearest square number is 25. So square root of 25 is 5. And then 5 take away 3 is 2, times 5 is going to be 10. So our answer is 10. To answer this question, we need to know what an equation, expression, formula, and identity is. So the formula is basically an equation but for real world things. So area equals pi r squared. It's where the letters actually mean something. Expression is just algebra without the equal sign, so 5x plus 3 would be an expression. An equation has an equals and it can be solved, so you can find out what x is or find out what a is. And an identity is true for all values of that letter. So an example would be x times x equals x squared. That's an identity because that's true for all values of x. So looking here, on the right-hand side, we've got 3x plus 2x. But if we imagine x is 10, so 3x would be 30 plus 2x would be 20, 30 plus 20, well, that will equal 5x, 5 times 10. And actually, this is true for all values of x. And the reason it's true for all values of x is we know that 3x plus 2x, this right-hand side here, equals 5x. They're the same thing. Now normally with an identity it's shown with 3 lines. Now in the exam, this type of question, it won't be shown with 3 lines because that kind of gives it away that it's an identity. But this question is definitely an identity. And you can't solve it because it's true for all values of x. So yes, x could be 10, x could be a million, x could be a third, x could be anything. To find the gradient, we need to find 2 points we know on this graph. So I'm going to pick that coordinate and this coordinate here. And we know that we need to draw a right angled triangle between them. And we find the gradient by the change in y, which is 3, over the change in x. But notice the change in x is 1, so it's going to end up being 3 divided by 1, which is just 3. So a different definition of the gradient is for every 1 we go to the right, how far up we go, which is 3. So here we're given a standard form number, and we're asked to make it an ordinary number, which is just a number you type into the calculator. So we're going to start off by writing the decimal, which is 6.2, and we're going to shift that decimal point somewhere that it will be the actual number rather than standard form anymore. First thing to point out is we look at the power. If it's positive, it means that our ordinary number is going to be a big number. If it's negative, it means it's going to be a very small number. Since this is positive, we know it's going to be a big number. So we're going to do 4 jumps, because there's a power of 4, to the right to make it a big number. So 1, 2, 3, 4. So the decimal point is going to be here. And we're going to fill in the jumps with zeros. So 0, 0, 0. So our new number is going to be 62 with 3 zeros, or 62,000. Now it's important to realise that we're actually shifting the numbers, not the decimal point, but it's a lot easier to move the decimal point in our working out. When you multiply powers with the same base, you add the powers. So we're going to do that here. We're going to add the 13 and the 4 at the top of this fraction. 13 plus 4 is 17, so it's going to be 5 to the power of 17. We haven't done anything with the 5 to the power of 5 at the bottom yet. When you divide powers of the same base, you subtract the powers. So we're going to do 17 take away 5, so it's going to be 5 to the power of 12. So the way this formula works is we have m, which is the final amount. The 2000 here is our initial amount. The decimal in here is our multiplier, and the power here is the amount of years. So the way multipliers work is they are the percentage divided by 100. So if we go the other way and times it by 100 to make it back into a percentage, it will be 102.9%. Now it says what is the interest rate of the bank. Well, the interest rate is always going to be 100%. Well, this 102.9% is 100% plus the interest rate, which will equal the 102.9%. So the interest rate is going to be the 2.9%. You always start off with 100%. So if I put £5 into my bank, I've got 100% of that £5, and then the interest rate is on top of that 100%. So our answer here will be 2.9%. So we're asked to find the vector 3a plus 2b. So we're going to start off by working out 3a. And so we just go times the top and bottom of a by 3. So that'd be 9 and 6. And to find 2b, we do exactly the same to the second one, but we're going to times it by 2. That'd be minus 2 and minus 4. And so to find 3a plus 2b, we're just going to add the tops together. So 9 plus minus 2. And add the bottoms together. So 6 plus minus 4. 9 plus minus 2 is 9 take away 2, which is 7. And 9 plus minus 4 is going to be 2. So the vector is going to be 7 and 2. We're going to start by focusing on the A and B, which is 8 and 16. So in the middle is going to be 8 and 16. The next thing we're going to focus on is the fact that A is all the multiples of 4. Now 8 and 16 have both already been taken because they're in the middle. So the remaining multiples of 4 are the 4 there and the 12 there. So the next ones I'm going to focus on is the A or B. So A or B is in A, in B, or in the middle. So if we cross out the ones we've already used, so we've already used the 8 and 16 and the 4 and the 12, that leaves the 1 and the 9. We'll cross that out of our other list. And there's only 2 left in our everything list at the top. We've got the 3 and we've got the 11. So on the outside we have 3 and we have 11. So the first thing we notice is the coefficients of the x's and the coefficients of the y's are different. But if we look at the y's, they are very similar. So we've got 3y and we've got 6y. So all we need to do is times everything in the top equation by 2 and then they'll be matching. So we're going to write out the first equation again. And what we're going to do is we're going to multiply everything in it by 2. And so I'm going to write that equation again, just so we can match up the equations nicely to be able to do our simultaneous equations. And I'm going to write the second equation just as it is, because it's already 6y. And get my bubbles in, because obviously we're working downwards. Now we're either going to be adding or subtracting these, and the way of telling is looking at the sign before the 6y's, the matching coefficient, and if they're the same, then we subtract. If they are different, then we add. Now these are both the same, they're both positives, so we are going to be subtracting. So we're going to subtract the top ones from the bottom ones. 10x take away 6x is going to be 4x. 6y take away 6y is nothing, which is good, because if we're left with any y's here, that means we've made a mistake. And 70 take away 54 is 16. And let's get our lines in, because we need to solve this last bit by dividing 4 both sides. And so we've got x equal to 4. Now that's only half the job, because we need to find out what y is. So what I'm going to do is just copy this first equation, but substitute in the value of x, which is 4. So 5 times 4 plus 3y equals 35. Get my lines in. And 5 times 4 is 20, so I'm going to take away 20 both sides to get rid of the 20. So we've got 3y equals 15. And then we're going to divide by 3 both sides. So we've got y equals 5. Now we can substitute in the values into the second equation. So 6 times 4 plus 6 times 5 does equal 54. I'm going to do just a quick multiplication grid. And what I'm going to do is I'm going to put the 2x plus 3 at the top, so 2x and then plus 3, and then 3x minus 11 down the side. Multiply them out, 3 times 2 is 6, so that'd be 6x squared, 3 times 3 is 9, so that'd be 9x. Minus 11 times positive 2 will be minus 22x, and then minus 11 times positive 3 will be minus 33. Get them all together, so we've got 6x squared plus 9x, because that is a positive, minus 22x minus 33, and we can see here that the plus 9x and the minus 22x are like terms, so we can add them together to make minus 13x, and that's our answer. So our answer is 6x squared minus 13x minus 33. You can complete a unique version of this paper by going to our onmaths site. onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing.